Hey guys, Mr. Milton here. Today we're looking at simplifying radicals number 2 notes. At the end of this video, you should be able to simplify radicals containing variables. At the end of this and you should be able to simplify radicals containing a combination of numbers and variables. There we go. Recall from last lesson, when we simplify radicals, we looked for pairs of numbers under the radical. We are going to do the same thing today with variables. Okay, so let's look at this. We have radical a squared. If we look at this, we can rewrite a squared as a times a. Okay, so we have a pair of a's, we take it out. Radical a squared is a. Let's do that same thing with radical a to the fourth. A times a times a times a. We have 2 pairs of a's. So we could write that as a times a, no leftovers, all right? And a times a is just a squared. Okay, looking at a to the 6th, we got a times a times a times a times a times a. I know, guys, I'm sorry. Okay, so we have 1, 2, 3 pairs of a's. So on the outside, we have 1, 2, 3 a's. We could rewrite that as a to the 3rd. Last one, we have a to the 100th, so we have 8. I'm just playing, I'm not going to write 100 times. Once we get to 100, we're like, wait a second, let's notice a pattern so we don't have to work so long. Okay, so here, as we look at our pattern, we had a to the 2nd power became a to the 1st. A to the 4th power became a to the 2nd. A to the 6th power became a to the 3rd. What's happening? When we take the square root, we are dividing our exponent by 2. Okay, so a to the 100th power, we have how many a's? 100. So the question is, how many pairs of a's do we have? 50. Okay, so square root of a to the 100 is a to the 50th power. Okay, as we look at this, what's true about this? All the exponents inside the radical are even. And the exponents on the simplified version are half of the exponent inside the radical. Okay, that's what we just talked about. Okay, and that's why there's no leftovers and just easily divisible. What happens when you have odd exponents inside? Okay, so let's look at it. We have a to the 3rd, that's a times a times a. So we have 1 pair of a's and 1 remaining. A to the 5th, a times a times a times a times a. We have 2 pairs of a's, so a squared, and 1 a without a pair. What about a to the 35th? Like we said, at this point, we kind of hope to find a pattern. Okay, and here's our pattern. Not really a pattern, but we already kind of know, hey, we got to divide by 2. So when we look at that, we have 35 divided by 2, and that gives us 17.5. Okay, what do we do with this fraction? Okay, well, we can say, okay, well, that means we have 17 full pairs of a's. So I can write this as a to the 17th power. And we're really, if we don't look at it as 0.5, if you guys remember from like 2nd grade when you first started doing division, you had 1 remainder. Okay, so it would be like, you would have written like 17 remainder of 1. Remember that? Okay, and so we have 1 remaining a. And that's here. 17 pairs of a's, 1 remaining a. Okay. So what's true about this? All the simplified versions have 1 variable left over under the radical. And there's never more than 1, right? Because if there were 2, we'd have another pair. If there were 3 even, we'd have another pair even though we still have 1 left over. So we should never have an exponent underneath our radical when we're done. Okay. The exponent on the simplified version is half of the even number right below the exponent inside the radical. Right? So it'd be like 34, 17, and then 1 left over. And that's basically all you need to know for simplifying radicals with variables. These ideas will be combined with the ones from last lesson as well as from the next lesson. So let's practice with practice problems here. Okay. All right. So how I approach this is really the same way that we approach exponents, the same way that we approach polynomials. We take it one kind of term at a time. So here for number 1, we have m to the, I don't want that open. We have m to the 6th, n to the 9th, p to the 3rd. So what I'm going to do is I'm going to kind of just handle all these separately. You don't have to write them separately like this, but I like to do it at least at the first day just to make sure that I'm like, okay, I'm good. I did everything I was supposed to do. So as I look at m to the 6th, 6 divided by 2 tells me how many pairs of m's I have. I have m to the 3rd power, 3 pairs of m's. N to the 9th, how many pairs of n's do I have? I have 4, because that's 8, with 1 remaining. P to the 3rd power, how many pairs of p's do I have? I have 1, with 1 remaining. Okay, and so now we have our multiplication problem, our rules, outside times outside, so I'll have m to the 3rd, n to the 4th, p, and then inside times inside. That's radical n times radical p. Okay, so that's basically it. Number 2, same kind of thing. We have a number and now we have variables, so we kind of mix them in now. But I handle it the same way. I want to deal with my number, deal with my variables separately. Okay, so talked about numbers last time. Our rules stay the same. Look for 2 numbers that multiply to give me 27. Only rules I can't use 1. So 9 times 3. What multiplies give me 9? 3 times 3. All right, so I have a pair of 3s and a 3 without a pair. Okay, x to the 8th, how many pairs of x's do I have? I have 4. 8 divided by 2 is 4. Okay, so on the outside I have 3, x to the 4th. On the inside, I have 3. Number 3, I have a squared b, radical a to the 5th b squared. So, stuff on the outside I don't want to forget. So I'm going to write it here. And now I'm going to separate this. I have a to the 5th b squared. How many pairs of a's do I have? Well, 4 evenly, so a squared with the 1 remaining. How many pairs of b's do I have? Just 1, no remaining. And then I have a squared b already here from the beginning of the problem. So I do my multiplication rules, outside times outside. And this is kind of like our exponent chapter a little bit, because a squared times a squared gives us a to the 4th. B times b, right? That's b to the 1st times b to the 1st. It gives us b squared. And then we have radical a. Number 4, again, we have 3x squared written on the outside at the beginning of our problem. We don't want to forget to include that in our answer. I'll write that here. Then I'm going to separate my numbers from my variables, handle those things separately. So as I look at 54, that's 9 times 6. 9 breaks down pretty nice into 3 and 3. 6 breaks down to 3 and 2. Okay, those are prime, nothing. So I can write radical 54 as 3. 3 times 2, radical 6. X to the 7th, I have 3 pairs of x's, because x to the 7th divided by 2 is 3.5. So 3 and an x remaining. And then we had the 3x squared from the beginning of the problem. So now outside times outside, 3 times 3 is 9. X squared times x to the 3rd is x to the 5th. Inside times inside, radical 6, radical x gives us radical 6x. All right, 5 and 6. Some multiplication here. Remember our rules, inside times inside, outside times outside. I like to multiply them together first and then do the breaking down stuff. You could break them down and then multiply. I just feel like that's sometimes gives you more work. So I'm going to multiply them together here. Remember, inside times inside. These are, everything here is inside the radical. Everything there is inside the radical. So we can multiply these two things together. So when I do that, 10 times 5, 50. G to the 3rd times G to the 1st is G to the 4th. H to the 4th times H to the 5th is H to the 9th. Okay, so now I'm there. I'm going to separate these things out, or at least deal with them separately, I guess, in my mind. This is how I'm thinking. I don't necessarily have to write it out this way every time, but I just want you guys to see my thought process here. So what multiplies give me 50? 25 and 2. Choose prime. What multiplies give me 25? 5 and 5. Have a pair of 5s. Okay, so 50 is 5 radical 2. G to the fourth, how many pairs of G's do I have? 2. H to the ninth, how many pairs of H's do I have? 4, with 1 left over. So now I'm going to multiply outside times outside. 5 is outside of the radical. G squared is outside the radical. H to the fourth is outside of the radical. So 5 G squared H to the fourth. And then inside of our radical, 2 and H. Okay, last problem here. I should have probably done that in a different color. Let me separate the answer from the question and work. Okay, last problem here. We have 4z to the third radical 21z times negative 2z radical 3z to the 10th. Really quick here, notice that this is not a distribution problem, right? We'll see distribution if our terms were separated like 4z to the third plus radical 21z and negative 2z minus or something like that. Okay, but notice that that's not what we see here. This is just a number times a number. Okay, another different way, just a different way to write it rather than just putting the multiplication dot in the middle. Okay, so as we multiply that, our rules stay the same. Outside times outside. 4 times negative 2, negative 8. Z to the third times z to the first, z to the fourth. Inside times inside. 21 times 3 is 63. Z times z to the 10th, z to the 11th. Okay, and so now I'm going to break this 63z up. 63 z to the 11th, breaking it up. Okay, I don't want to forget about what's already on the outside here. 9 times 7, 7's prime. 3 pair of 3's. So 63 breaks down to 3 radical 7. Z to the 11th, how many pairs of z's do I have? Well, I have 5 pairs. 11 divided by 2 is 5.5. It means I have 1 remaining. Okay, and then I already had negative 8z to the fourth at the beginning of the problem. So I'm going to do this in a different color here so that we can see easily what it was. So negative 8 times 3 is negative 24. Z to the fourth times z to the fifth is z to the ninth. And then radical 7, radical z inside by inside is radical 7z. Okay, so there we have it. That is simplifying radical expressions with variables, okay? And added a little bit of variables to our numbers. All right, see ya.